Hello everyone, my name is Marianne Chevalier. By the way, the presentation is going to be in English. And my interest, I'm a master's student in sociology, and my interests lie in novel computational methods to analyze text data. And I'm glad to be here with my colleague Magdalena to present our research project.
Yeah, hi everyone. Magdalena, I'm a PhD student in psychology, and my dissertation focuses on the need for control and how it fuels populist and authoritarian attitudes. So the starting point of this project was that both Marianne and I were working on the same data, an open-ended survey question, but we use very different methods to analyze it and make sense of the data. And that's why Eric had this great idea of why not compare the two methods and compare the results and see where the differences lie and where the commonalities. So this is what we're going to present to you today. First, I'm going to walk you through our research question and the data we have. Next, I'm going to present to you the manual coding approach and my results. And then Marianne is going to walk you through LDA and go a little bit into the technical details of this method and show her results. And then in the end, we're going to wrap up comparing the two approaches and the results. And and then we'll have lots of time for discussion with you. So COVID-19. It's been a big challenge for, I guess, all of us and very unsettling. So humans have a tendency to seek for answers, seek for explanations, particularly when events are unsettling. And with complex crises and complex problems such as COVID-19, there is not just a single answer or a single cause that created this mess, but it's complex. There's many different answers. And this is why it's interesting to investigate what do people think? What do people think is responsible for the crisis? To gain an idea, we can, for example, look at public discourse and see how COVID-19 is discussed in the media. We know that in the beginning there were lots of mentions of China, Chinese wet markets, but then as cases rose in Canada, the discussion, the focus changed towards governments, what they do, what they don't do, and to people not complying with the rules. But what we, Marianne and I, are really interested in is not the media or newspapers, what politicians are thinking, but what are ordinary Canadian citizens thinking? What do they think is responsible for the crisis? And how do their beliefs on the responsibility change over time? And our basic assumption is that the beliefs on the responsibility for the crisis, they reflect the general development of the crisis. So it all started in China, and then COVID-19 came to Canada, and that it also reflects the public discourse. So at the beginning, there would be more mentions of China and wet market, and then mentions or references to government decisions and non-compliance increase at later waves of the survey. So the data we have is a longitudinal Canadian survey. It's filled out online, and participants answered an open-ended question, which reads as follows: who or what do you consider most responsible for the current COVID-19 crisis? And there's about 2,800 respondents answering that question at the first time point, but then with increasing time, the number of respondents drops up until roughly about 1,700 at the 10th wave. Manual. Oh shit, I did something wrong. Here we go. yeah, so manual coding, that's what I did. Generally, researcher comes up with a coding scheme, and this coding scheme is based on deductive and inductive reasoning. So if, for example, you want to research populism in social media posts of politicians, you take the definition of populism from theory, that's the deductive part, deductive reasoning, that is the antagonism, the quarrel between elites on the one hand and ordinary people on the other hand. And with that definition, with that theory in mind, you generate the coding scheme. And then as you go through the data, as you read the posts, you adapt the scheme. And you realize, oh, well, actually there's different types of elites. There's the economic elite, then there's the political elite, and there's the media, and you realize, oh, I have to make a distinction between those types of elites, and this realization comes as you read or you see the data. And then the sufficiency of this coding scheme is assessed via inter-rater agreement. So you have two independent coders go through the same content and rate the content based on the coding scheme, and then you assess the extent to which the two coders agree. And if you can, for example, there's different scores and different things you can compute. For example, one example is just percentage of agreement, and if it's above a certain threshold, for example 90%, then it's good, below it's bad. So you have to then iteratively improve your scheme. And there's different types of softwares you can use. In my case, I just used Excel and then merge or input the data into a statistical program for further descriptive analysis. So now moving on to our specific case and the data we use, I did a literature research for the deductive reasoning, and based on the literature on compensatory control, I realized that people have an innate need to know about contingencies, to have a sense of a structured, ordered world, and to reinstate that a sense of order and structure, they may basically blame anything, as long as it's viable. So, for example, in the case of COVID-19, blaming aliens may not be a common answer because people actually don't believe in it. But as long as you believe in that this thing or person caused it, it's a proper or answer that can be expected. And based on social identity and based on the literature on populism, I know that people distinguish between in-groups, out-groups that are, for example, ethnically and national, along ethnic and national lines, but also between ordinary people and elites, those at the top. And following these categorizations, I developed the first draft or the first version of the coding scheme. And then I, together with Eve Picard, who helped me a lot in this research, we coded a small share of the answers and assessed our inter-rater agreement. And then it was still too low, so I adapted the scheme. And then again, we coded a share of the answers and coded inter-rater reliability and adapted the scheme and so forth until we reached an acceptable inter-rater reliability. So now I'm gonna move on to the results or the categories and their frequencies. This is, I'm gonna walk you through it. So I have several main categories. They're displayed at the top. For example, let's start with the category countries.
those are answers referring to political entities. So, for example, USA, Canada, or China. So any answer referring to China, Chinese, would be in that China category. And the frequency you can see, for example, China is a big chunk. It's about 30% of respondents mentioned something with China across all waves. So that's an average. On average, about 30% of the respondents mentioned something with China being responsible for the crisis. And then another main category would be the general population. And there you have references to behaviors of people, for example, non-compliance, but also to humans in general, or everyone being responsible. And then you have references to elites and institutions, leaders. A lot of people mention something like, yeah, governments not being prepared, governments not acting fast enough. That would be the wrong action. And then other respondents say something like, yeah, governments in general, world leaders, that would be just the unspecific governments category. And then we have lots of other answers referring to economic elites, such as pharmaceutical companies and airlines and that kind of stuff. And then we have also a big chunk of answers belonging to non-human factors being responsible. One is nature, and the other one is coincidence. So answers like, these things just happen, or no one is responsible. And then here finally, respondents saying they don't know who's responsible. And responses refusing to answer, or giving answers that do not make any sense. So I want to zoom in a little bit into the China category because it's so big, and it's going to be important also for the part that Marianne is presenting later. So here you can see separated across the wave the subcategories in the China category. And you see the biggest chunks are mentions of China in general. So those are answers that are most of the times really short. So people saying China. So one-word answers, or Chinese Republic of China, something like that. And another big chunk is the Chinese government, something like
Chinese Republic of the China Republic or something.
Yeah, CCP. What is it? Chinese
Communist Party.
Exactly that one. Yes, and then like smaller parts are references to specifically to the Chinese habits and Chinese culture and Chinese people. That's the green, and the light gray thing is like Chinese wet markets. And then we have very few people referring to the lab in China. So, and then I want to show you this thing. Here you can see how the categories develop over time. So the x-axis shows the time points, the waves, and the y-axis shows how frequently each one of these categories was mentioned. And I don't want to go too much into detail here. Most of the categories don't change that much, or most of the categories' frequencies don't change that much over time. But what does change is the frequencies of mentions of China, so that drops over time, and the frequencies of non-compliance, so that increases over time. And then we also have a little bit more mentions of Canada towards in October of 2020 compared to the beginning of the pandemic. Yeah. All right. So now Marianne's.
I'm just going to adjust the screen first. Okay. And here. Okay. So now I'm going to talk about the latent Dirichlet allocation. So I'm going to focus more on the method first, and then I'll talk about the results. So my goal with this section is to help you understand the main ideas of the method. It's going to be a bit technical, but it's necessary to understand the method. And basically, latent Dirichlet allocation, for short LDA, is what we call a topic model. So a topic model is a type of statistical model for describing the abstract topics that occur in a collection of texts, of documents. It's not done manually. It's an unsupervised method, which is done by using coding. So the goal of LDA is using Bayesian probabilistic model. It's to identify clusters of terms that have a simultaneous presence within documents. And so LDA generates topics based on word frequency from a set of documents. And also LDA is a way for us to discover hidden or latent topics in a collection of texts. And so before running LDA, like any data before we model, we need to pre-process the text data. So these steps are important for data accuracy and quality. It makes the data set more complete and efficient to perform data analysis. So these steps will depend on the research. They can be done on on the softwares like R and Python with packages like TextMiner and TextStem. And the result of the pre-processing steps is what we call a document term matrix, which is for short DTM. So for example, here we have a document which is unprocessed. We have in the first column, the first example, the document, which is the participant, and we have the answer in the second column. For example, first answer is unsafe food in wet markets in China. And the result of the DTM is a matrix where we have the documents in rows and the words in columns, and we have the frequencies there. So I've been talking about documents, I've been talking about topics, but what are these terms? So first I'll talk about what is a topic. So each topic can be represented as a weighted list of words. The words within a topic have their own probability distribution. For example, the word China here in topic 1 has a probability of 6% to belong to topic 1, but the word China can also be present in more than one topic and have a different probability to belong to that topic. So in topic 2, we have a probability of 4%, and in topic 3, it's a probability of 3%. And by the way, this is a fictional example. It's not from the data set. It's just for show. Now, what is a document? So a document is a unit in a collection of texts. For example, in my research, a document is a participant's answer for a specific wave. We have the ID 1751, which is the participant, and its answer for wave 1. Also, a document can be represented as a distribution of topics. For example, in this visual representation, document 1 has a 30% chance, probability to belong to topic 1, and it has a 50% probability to belong to topic 2, and so on. And this means that the participant 1751's answer can be represented by one topic or more than one topic. So this is the graphical model representation of the smoothed LDA model. I won't dwell into too much details because it's a bit complex. Professor David Blei talked about this plate annotation in his article on LDA from 2003. And by the way, this is the first article that was written on this method. I've put the reference at the end of the presentation for those who are interested to learn more about it. And basically, the boxes are objects that are modeled in the generative LDA approach. The K box represents the topic level. The M box represents the document level. And the N box represents the distribution of words in the document. But my focus will be more on alpha and beta, because I'll come back to these two parameters later in the presentation. And so alpha is the distribution of topics within a document, and beta is the distribution of words within a topic. And now, how LDA works. So once we apply the pre-processing steps, we get our DTM, document term matrix, and now we're ready to execute LDA. So when executing LDA, we have to input these following parameters. There's the alpha and the beta I just talked about. Alpha, which is the Dirichlet parameter for the distribution of topics per document. The beta, which is the distribution, the Dirichlet parameter for the distribution of words per topic. And so when we have a higher alpha, it means we have more topics per document. And when we have a lower alpha, it means we have fewer topics per document. And when we have a higher beta, it means more words per topic. And a lower beta means fewer words per topic. We also have to compute the number, K number of topics, and N, which is the number of Gibbs sampling. And Gibbs sampling is used for statistical inference. And so we've input these parameters, we executed LDA. LDA produces two matrices. First, there's the topic distribution over documents, and then the word distribution over topics. And with these two parameters, with these two matrices, now we're ready to do some coding to get a bit more information about our topics and the words within our topics. And so why using LDA compared to other computational methods? So LDA has a greater accuracy than other computational methods. For example, LSA, which is called Latent Semantic Analysis, has a lower accuracy than LDA. LDA yields a better disambiguation of words and more precise assignment of documents to topics. And what do we mean by better disambiguation? So some words belong to more than one topic with different probabilities, but the presence of specific co-occurring words in a document will disambiguate their usage. So for example, if I have the word Chinese alone, we don't know if we're talking about Chinese food, Chinese government, or Chinese people, but the co-occurring words next to the word Chinese will disambiguate the usage of the word Chinese. So if I have government following Chinese, then I know I'm talking about the Chinese government. And also, LDA is a well-defined generative model. It generalizes easily to new documents, unlike other methods like latent semantic analysis, LSA, which I talked about a bit previously, that don't provide a generative model of text. And so in this case, we can't generalize to new documents. And also, LDA attenuates overfitting better than other topic models, like, for example, PLSA, which is probabilistic latent semantic analysis. And this is especially if the size of the corpus increases. So this is because in LDA, unlike in PLSA or LSA, we compute the different parameters, which are alpha, beta, and the number of Gibbs sampling. And this attenuates the overfitting problem. So now,
Can you just specify a little bit what you mean by overfitting? What is overfitting in terms of topic model?
Overfitting is like the data, they correspond a lot to specific parameters, and you can't generate the data on new sets of documents. And so now I'm going to talk about the methodology for LDA. So first I'll talk about the pre-processing steps. And then I'll talk about more specifically the LDA part. So these are the different pre-processing steps I took to analyze to pre-process the data first. So first, there's translation of written answers into English because there were also French answers in the data set. There's also correction of spelling mistakes because LDA works with a dictionary and misspelled words are not in the dictionary. And so if we kept the misspelled words in the analysis, we would have less data quality and accuracy. There's also word replacement for further standardization. So in the dataset, participants, when they referred, for example, to the United States, they used different words. For example, US, USA, America, but all these words were converted into United States. Also, there's removal of stop words, punctuation, and numbers. And stop words are words that are filtered out because they carry very little meaning. So they can be determiners, for example, the, a, and, or prepositions, for example, above or across. There's also lower casing and lemmatization. Lemmatization is considering the context of the word and converting it to its most meaningful base. For example, the words changes, changed, and changing would be converted into change. As for the modeling part, I used a LDA pipeline, which has an automatic parameterization of alpha, beta, and the number of Gibbs sampling. And so we only had to choose the number of topics. And so I chose 9 topics based on a score of model stability and qualitative assessment on a prior exploratory analysis using LDA between 5 and 20 topics. The number of iterations was 25. So I ran the LDA 25 times. And in these 25 iterations, we had the score of model stability. And I chose the LDA model that had a better score of stability. And the model was also produced on each wave separately. So for example, the model was run for participants of wave 1 only, separated from wave 3, wave 5, and so on. And I used the R package text miner to execute LDA. So these are some descriptive statistics. This is not something that we get from LDA, but we can produce them after the pre-processing part with the function summary in R. And we have here the mean, median, minimum, and maximum number of words. The mean is between 3.5 and 4.6 words. The median is between 2 and 3 words. There's a minimum number of 1 word, because like Magdalena said earlier, there are some participants that mention China only, or travel, for example. And the maximum number of words varies throughout the waves. This is another example of what information we can get after the pre-processing steps by using the package text miner on R. So this is the top 10 words in the open-ended question mentioned by participants for wave 1. And so the word that was most mentioned is China for wave 1. Then there's government, Chinese, virus, people, market, no one, lack, animal, and World Health Organization. This is an example of what kind of information we can extract from LDA. And so this is the dynamics of Lda Topics. I used the topic probabilities provided by text miner and the numbers of answers per waves to generate this graph. And so in the first waves, the topic Chinese government and World Health Organization and wet markets are more prevalent. And then as throughout the waves, the topic people not following guidelines, which is in thick blue, is more and more prevalent to be the most prevalent topic in wave 10. And there's a category which is other. So this category comprises topics that don't recur throughout all the waves. So there are topics like animals, world, countries and leaders, and unknown. All the other topics are recurring throughout the waves. So as we could see in the previous slide, there were recurring topics and there were non-recurring topics. And so I gathered the plot of 5 most common words of these topics in the following slides. And I used the function ggplot2 to get the plots. So for topic Chinese government and World Health Organization throughout the waves, so the top 5 words belonging to this topic don't change very much. For wave 1, there's government, Chinese, China, World Health Organization, and there's also United States. Like Magdalena said earlier, there were some mentions but that were referring to the United States and Trump. There's also Chinese Communist Party that comes up in waves 5, 8, waves 5 and 8. And this is it for the topic Chinese government and World Health Organization. As for the topic wet markets, this topic doesn't change very much also throughout the waves. So for wave 1, there we have the words China, market, wet, animal, and Chinese. For the topic government slow response, it changes a little bit throughout the waves. So in wave 3, we have 2 topics belonging to this government slow response. There's a first topic which is on the China slow response to the COVID-19 or lack of preparation. And there's a topic which is more focusing on the local government's lack of preparation and slow response. And throughout the waves, we can see some recurring words, which are lack, government, slow response, enough, poor, and action. As for the topic travel, the word China is in the top 5 words from wave 1 to wave 5. And then at wave 8, the word Canada comes up. And at wave 10, it's the word people. For the topics no one and nature, from waves 1 to 3, these topics were merged together. So no one refers to people who don't blame anything for COVID-19 crisis. And nature is about people blaming Mother Nature or the environment or nature in general for the COVID crisis. But then at wave 5, the topic splits in 2. So we really have a topic which is on no one and a topic for nature. As for the 5 most common words for the topic people not following guidelines, so the topic comes up 1 time between wave 1 and wave 5, and in waves 8 and 10, the topic comes up 2 times. So in waves 8 and 10, there's a first topic which is on generally people not following guidelines, not following the rules concerning COVID-19. And there's also another topic which is on people that are not implementing specific actions. For example, wearing the mask or socially distancing. This is the plot of the 5 most common words of other topics that were not recurring throughout the waves. So in wave 1, there's a topic about animals and nature, another topic which is on food and health practices. On wave 3, there's a topic about animals. In wave 5, the topic contains virus, China, spread, country, and unknown. In wave 8, there's a topic about with the words China, world, virus, Trump, and no. And in wave 10, there's a topic about the Canadian government. So Magdalena will talk about the summary of our research and some comparisons between our results.
All right, so what we can see is that in the manual coding, we have a lot more categories or topics than in LDA. But remember that the number of topics is really something that the researcher specifies in LDA. So Marianne computed different solutions with different numbers of topics, and 9 topics was really the best fitting solution that also made sense to Marianne, because when you have more topics, the same topics would reappear several times. And that, then where manual coding and LDA are really similar and overlap is on the topics of nature and no one, and the topic of non-compliance. We have fairly similar frequencies, and the content, I would say, is also really similar. But we do also have some differences, and that refers to the category of travel. And I think this is really a great example of a category that is unseen to the human eye, in this case unseen to me, because I have the theme travel in several different categories. For example, I have ordinary people traveling, and then I also have governments not closing borders, governments not implementing testing at the airport, and that is falls under the category wrong action. So, and there's the theme of travel that's subsumed in 2 different categories, while in the LDA it's really grouped in one. Another where the results diverge is the government response and Chinese government. The China thing, that's also something I would like to go a bit into detail. Here I have basically all the mentions of China grouped into the general category of China, and then within that category distinctions between who in China was it. And the LDA, Chinese government, only refers to the red subcategory of Chinese elites and governments. And
what's interesting in this in this graph is the fact that well, first, China in general, like the blue lines here, refers to mentions, if I'm correct, of participants who say only China, like one word. But as for the LDA coding, it goes with the fact that LDA computes and generates topic based on word frequency. So there's, like, we have the red part here, which is elites, and I have a topic which is on Chinese government. And there's also like in gray, there's a topic about wet markets in the manual coding, and there was a topic that emerged in the LDA, which is on wet markets. But those categories that are smaller, for example, lab, they were not present in a specific topic, which is only referring to the lab. They were in another topic. So this is to say that LDA generates topic based on word frequency. And just by the way, also, so for the topic Chinese government and World Health Organization, this is another example of a topic that is based on word frequency, because lots of participants, they said when they said Chinese government in their answers, it was followed by World Health Organization often in the time.
Yeah, and I have to go back here. So for the development of the frequencies across wave, we both find that references to non-compliance are more frequent at later waves. And in the descriptive findings of the word frequencies and in the manual coding, we also see that China is less frequently mentioned at later waves compared to earlier waves. But yeah, that's something we do not see in the LDA.
Yeah,
mostly because the one word answers are not captured in LDA. Yeah, so I think manual coding is a really great method to analyze open-ended survey questions.
Competition?
Yes. Because it's super easy to interpret. You get the categories and they make immediately sense to you. You know what they mean and you can interpret it.
Yeah, I see, but you know, categorization is subjective. Like there's danger in confirmation bias, and it's difficult to reproduce also.
Yeah, I see what you mean. Like my ideas as a researcher are really reflected in the scheme and how I group or categorize the answers. But we do have some methods to overcome that. For example, the inter-rater reliability. So that way we can make sure it's intersubjectively valid. It's not just me who sees these categorization, but also another independent person, researcher, agrees on this categorization. And another great advantage is that it's possible to understand like some aspects of natural language, like irony or metaphors. Yeah.
I see that, yeah, manual coding is able to capture natural language, but it's time consuming.
Yes, that's true.
Hey, but I have a method that is less time consuming. So it's called Latent Dirichlet Allocation. And one of its strengths is the fact that it's possible to discover latent topics unseen to the human coder. For example, in the manual coding, you had a theme on, you have like several categories for travel. But in LDA, there was one whole topic that was regrouping dimensions of travel.
Yes, I see that, but to repeat myself, some aspects of natural language might not be captured in LDA because, like, you have, for example, the one-word answers are all that information is basically thrown away in LDA.
It's true, and I understand this. And like, for example, in the data set, lots of participants, they used informal sentence structures. They answer as they speak. They use like informal expression and terms. And so, but you know, LDA is a reproducible method. We compute different parameters, which are the alpha, the beta, and the number of Gibbs sampling. And in the LDA pipeline I used, there was a score of model stability I could generate when executing LDA.
Yes, I see why that's a strength, but I'm not entirely sure the method is really or completely objective. You also take some decisions as a researchers, and the results really depend on decisions you take. For example, considering the pre-processing steps and also parameter settings, for example, the number of categories you choose.
I see what you mean. But there are lots of articles talking about how to perform the pre-processing steps and also the decisions that we take to do the pre-processing steps are deliberate. We think about it consciously,
yeah.
the word. And we elaborate on this in the coding part. So we have all the different steps of pre-processing. We leave a trace in the coding aspect, for example, in R on Python. As for the parameter settings, there's an article written by Tang and al. In 2014. I've put the reference at the end of the presentation. And they talk about guidelines on how to choose the different parameters. For example, if you have a lower number of topics per document, they suggest using a lower alpha, for example, a value of 0.1. And also in the LDA pipeline I used, I didn't have to choose the different parameters, alpha, beta, and number of Gibbs sampling, because these parameters were provided by the LDA pipeline based on model stability. So as I said earlier, I run the LDA 25 times. And for each of these 25 times, I have a score of model stability. And so I chose the model that had the best score of stability. And, sorry. So, you know, Magdalena, it's like LDA is an opportunity for us to expand our research possibilities. We can research books, news articles, tweets, social media posts, long interviews, speeches, scientific articles, video and audio verbatim, all over the time. As long as they are in a computer, we can research them from the 1900s until today. We can analyze millions of documents. And, well, the internet has been present for the public since like 25 years. But there's so much richness of information online also. There's lots of interactions that are happening online on the forums, social media like Facebook or Twitter and other kinds of medias. And so LDA is a way for us to analyze this information to their full potential.
Okay.
You win.
Yes. And so the highlights of the approach is first, for short text, like our open-ended survey question, LDA and manual coding, they complement each other. So for the manual coding, it provides us with a theoretical scheme for the coding. And LDA is a way for us to get another perspective on topics. But LDA is great for mid-range to long text, like news articles I talked about, social media posts, longitudinal text data we want to analyze. We can analyze millions of documents, as I said. And researchers, they develop and they propose new methods all the time. It's either to address issues or to propose new models to analyze text. And so we say that computational methods are the future of qualitative data analysis. And we want to have your opinion on this. We want to engage with you. Do you have any questions or comments you want to make? And we want to thank you for your listening. So, 47 minutes.
Le A avec l'accent.